Hi. So today we're going to be working on lesson 5, Into the Unknown. We're going to see what is there. So we're on page M371, and this was our do now. So please, if you have not done that already, please work on the do now. And so now that you've worked on the do now, because you've paused, right? So this is going to, we got x equal to 4. And if you think about it, right, well, what the square root of what will give you 2? And you were like, well, the square root of 4, right? Square root of 4 is going to give you 2. There we go. Because 2 times 2 is 4. And then the cube root of x is equal to -2. So if you want to think about it in the reverse way, well, if it's -2, -2 times -2 times -2 will give you a -8, right? And that would, because it's cubed, right? A cube root, I should say. So x is equal to -8, just like that. And then, and if you do want to check, well, let me see if I can find my calculator. And on Desmos, we can just go with, I'll just make that a little bit smaller because you don't need the graph. If you have your cube root, remember you got your function, and you go to miscellaneous, and you go to that nth root, so that you could plug that in and you go just -8, just like that. And you see -2. That's the check for that. And then, and the square root of x is equal to -2. And some people had said, well, maybe it's 4. Well, we already know it can't be 4 because the square root of 4 is equal to +2, not -2, right? And then somebody had said, well, what about -4? And then we know that this gets us into the imaginary world, right? And so this is going to be actually 2i. So we actually can't have, there's no x where when we square root it, it'll give you a -2. It's not possible. It's always going to be positive. Right? So this is what we call no solution, just like that. And the learning goals for today, or learning targets for today, is going to be, we're going to use properties of equality to solve radical equations. Now, you already know what the properties of equality are. You just didn't know that that was its name. You know, whenever you add 3 to both sides, or when you divide by 6 on both sides, or square root both sides, right? What we're doing to one side of the equation, we're doing to the other side of the equation. That's the property of equality. And so, and then we're going to be solving equations as well as identifying extraneous roots when solving radical equations. All right. So, yeah, so we'll figure out what extraneous, okay, extraneous is basically something that's irrelevant is what the dictionary says. But in our case, extraneous meaning like unnecessary, well, it doesn't work. That's what we're talking about. So we're getting a solution that's not really a solution. So we'll talk about that. And so on to the next page, we compared these two equations right here. One on the left is a quadratic equation. The one on the right is a radical equation. And notice everything's exactly the same, except one is a square and one is a square root. And so notice that we solve them exactly the same way, except at the very end, instead of we're going to square root both sides. And when we do that, we have to remember to do the plus or minus. And so here we get 2 answers. And if we take a look at the other one where we have the square root, we're solving for the square root, you're going to square both sides and we only get 1 answer. So that is a little bit of a difference. We don't have to add in plus or minus or anything like that because there's only one solution for that. Only the square root of 81 is equal to 9, not like the -81. That would give us imaginary numbers. We don't want that. And so here's our check right here. On radicals, we're going to have to do a little bit of checking. If you had other teachers before who told you, you know, when you have the solution, go back and plug it in and check to see if it actually works, right? We're going to really need to do that here because sometimes they won't work. And maybe you'll see why. So we're going to plug in 81 where the x was, and order of operations says that the square root of 81 we got to do first, because think about it, remember that's like the exponent, and that's going to be 9, and then we multiply, so 2 times 9 is 18, and then we get 13. And notice here I did put in question mark because we're checking, so we don't know for sure whether that is actually equal. So we're like, does it equal? I don't know. And so we're going to go all the way up until 13 is equal to 13. Once you get the left equal, completely equal to the right, then we're going to put like check mark, we're done. That's good. All right. And even here, we were like, Miss Lee, 18 minus 5, we all know that that's 13. Just go the extra step. Okay. Make me happy. It's not just about me. So there is that. Going on to the next page, we basically just did these two problems. I know they're already worked out for you here, but this is, again, a good way to practice problems, right? If you're like trying to study, take these worked examples and do them yourself. Like do it on a separate sheet of paper if you're too like tempted to look over and see you, right? And do it yourself. And then also make sure you check, and they also do the check here. And then you could always go back and take a look. What did they do? Or did I mess up? Where did I mess up on? So it's an easier way for you to see that because it's already worked out for you, as opposed to another question which doesn't have any answers on it. So again, here, you're just going to solve it like how you would normally solve for x, right? So we're going to subtract 7 on both sides, and then you're going to divide by 3. And once you get the square root by itself, that's when you square, right? And the question arose, well, do you have to square at the very end? Can you square it before then? And yes, you can, 100%. Like for example, once you get to 3 root x is equal to 18, you can technically square here. The problem is that people don't do it right when they do it here. So you need to also square the 3, not just the square root of x. So that's where most people mess up on. So, if your teacher before had said, yeah, you don't do that ever, that's probably because they wanted you to avoid that mistake. But you can do it. So 3 squared is 9. So this would actually be 9x. Remember the square root and the square cancel out. And equal to 18 squared, which is 324. That's a 24. Okay. And then you divide both sides by 9 and you get x equal to 36. If you notice, it's the same answer, right? So technically you could do it up here. It's just a lot more complicated because you're going to have to actually like distribute, like the box method and all that kind of stuff. And why make things more complicated when it doesn't need to be, right? And then here's our check over here on the right. We just plug in 36 right here where the x is. And we put a question mark over the equal sign because we're not sure, right? So 3 root 36 plus 7 all the way down, 25 is equal to 25. Yes, 100%. That is true. So if you notice, that is exactly what they got. Happy days. We're going to do the same thing for the second one. And if you notice right here, we square first. And you may be like, well, why didn't we subtract first? Because before we subtracted 7 first. And so please notice that this plus 7 is outside of the square root. And here the plus 1 is inside the square root. So that's why we square first here, because it's actually inside the square root. So that's not actually a plus 1. Okay, so we got to get rid of that square root first in order to deal with the plus 1. Think of them like parentheses, right? So that's why we square first here. And then once we get that, we get x plus 1 is equal to 64, right? Because x squared, 8 times 8. I mean 8 squared, 8 times 8, which is 64. Then we subtract the 1 and we get the answer of 63. And here is our check right here. And we just plug in that 63 back into x, and we get 63 plus 1, which is 64. And then we know that the square root of 64 is 8. So yes, 8 is equal to 8. Happy days. All right, moving on. So this is the part right here where we're talking about extraneous solutions. So one of these is actually an extraneous solution. So if you take a look right here, extraneous solutions are solutions that result from the process of solving the equation, but are not valid solutions for the equation. Basically, you get an answer that's not actually the answer, right? So an answer that's not the answer. Okay, solution that's not a solution, right? That's basically what it's talking about. So again, we did this. I tried to color coordinate them a little bit. Technically, we don't need all that. And so if you take a look at these ones, please make sure if you did not do all of these in class, pause this right now, do it yourself. All right. And or if not, if you're like, I need a little bit of help, okay, then go to that part. Right. Again, so for number A or letter A, again, the square root is by itself for it. So we're going to square both sides and we just get 2x equal to 9. Then we're going to divide both by 9 and we get x is equal to 9 over 2. Now I like to leave it as a fraction because that's the most precise. Because once we get to decimals, like if it's a decimal that kind of repeats, or it's really, really long, first of all, it's really long to write down. And second of all, it won't be, when we check it, it won't be exact because you round it, right? So here we're just going to plug that in. And, I know you don't like fractions, or maybe you do, I don't know. But this one, it's not painful because it should cancel out. So once you plug in the 9 over 2 here, 2 divided by 2 is 1, right? So we call that canceling out. And so all we have left is the square root of 9. Is that equal to 3? Yeah, well, the square root of 9 is 3. So yes, that checks out. That means our answer is 9/2. All right. And so for B, let's try letter B. Notice again, we don't have anything outside the cube root. So we're just going to cube both sides first. And we're going to get 2x minus 3 is equal to 8. Again, just basic, remember like algebra 1 stuff, right? So add 3 to both sides, divide by 2, and you get x equal to 11/2. If you had 5.5, that's fine as well. If you did this in your head and you're like logically reasoning it out, that's fine too. Just make sure that you know how to do it the algebraic way. Because once it gets to be more complicated where you can't do it in your head, like it's not a nice number like this, then it'll be a lot easier to do algebraically. So we're going to plug that back in, and note the 2 again cancels out, which it should. And we got 11 minus 3, and 11 minus 3, which is 8. And then cube root of 8 is 2. If you did not know that, use your calculator. All right, but you have to think to yourself, what number, when you multiply it 3 times by itself, will give you 8? And that would be 2. Next one. Oh, note right here, we do not square immediately. We do divide by 4. Can you square immediately? Yes, you can. You're just going to have to deal with bigger numbers. I personally like to deal with smaller numbers. So we're just going to do that first. So dividing 4 on both sides, now we square root because the square root is by itself. And then so we're going to get x minus 6 is equal to 4 because 2 squared is 4. And then just to get rid of that minus 6, we just add 6 on both sides, and then x is equal to 10. All right, and we do our check right over here, and that's what you should get. It does work out. And so yeah, x equal to 10 is an answer. And for this next one, D, again, we got the square root by itself, so it's going to square both sides first. We got 2x plus 1 is equal to 25, because 5 squared is 25. Subtract 1, get rid of the 1, then divide by 2, and your answer should be 12. And our check is way over here on the right. So remember, just plug in 12 in for x and do the work. Simplify the left-hand side, and you'll notice, oh, a square root of 25 is equal to 5. So yes, it does check out. And then letter E. Let's take a look at E. Yeah, so notice that the cube root, it is cube root, not 2 to the third power, it's cube root. It is not by itself, so we are going to just subtract 16 first, and then we're going to divide by 2, right? So we're going to get cube root of x is equal to negative 8 to the third power. So this is just negative 8. And then, sorry, and then we cube both sides because we want to get rid of the cube root. So we do end up with negative 512. We're like, ooh, that's a really big number. Is that right? Don't know. So let's check. So we're going to put it in. So here is 2 times the cube root of negative 512 plus 16. Does that equal 0? And that actually, when you put it in the calculator, is negative 8. So 2 times negative 8 is negative 16, which cancels out that plus 16, right? So then we do end up getting 0 is equal to 0. Yep, totally checks out. It is correct. Now you're like, where is the extraneous solution? Well, here we go. Here it is. Are you ready? So if you take a look here, the square root is not by itself. So we're going to subtract 9 on both sides. And then we get square root of x minus 1 is equal to negative 1. So far, so good. So now we're going to square both sides. And we get 3x minus 1 is equal to 1, positive 1, right? Because negative 1 times negative 1 is positive 1. And then solve for x, and we get x equal to 2/3. So now we're going to check it. Plug in 2/3 in for x. 3's are going to cancel out. We just get 2 minus 1. And 2 minus 1 is 1. And square root of 1 plus 9 is 10. Now 10 does not equal 8. So notice I put a little slash right there on the equal sign to show that it's not equal. Therefore, it's not a solution. And technically, you could have, if you realize this, if you saw, right, if you looked at this step right here, you saw that the square root of something is equal to a negative number. And remember our do now, right, number 3, like it was equal to a negative number. And I was like, it doesn't work out. That's the indicator. You're like, oh, wait, that should have been a red flag. We're like, oh, that doesn't work. It's not a solution because you can't have negatives for square roots, right? So that was the sign for that. Now we're looking at Marty's, right? Marty's, This is a little bit upper level, but that's cool. You are totally, completely able to do this. These are all things that we've learned before. We're just putting it all together, right? And so I'm going to do this over here on the right so that you can kind of see all the different markings on there. So x minus square root of x is equal to 2, right? And then so first step was to, let me just actually do these in different colors. So first step was to subtract x on both sides, because we want to get rid of the square root of x, right? And then we're going to get negative square root x is equal to negative x plus 2. Now, we want to get rid of this negative here. So what we're going to do is we're going to square both sides. So we're going to square this whole thing. And, oh, haha, just kidding. Did I say square? I meant multiply by -1. Multiply by -1 and multiply this by -1. So which gets us square root of x is equal to x minus 2. Remember, we're just distributing out that -1. And so that's what it's going to look like. So now we're going to just square to get rid of the square root here. So we're going to square both sides. And what we're going to end up getting, so right now we are right here at this point right there. Do you see? Same, right? And then we are going, so the square root and the square is going to cancel out. So we just get x. And this one, you can't just go, oh, it's x squared minus 4. Doesn't work like that. Remember, this is actually x minus 2 times x minus 2. So x times x is x squared. X times the -2 is -2x. Then we're going to do distribute the -2. So we're going to go -2 times x, which is -2x. And then -2 times -2, which is +4. And we're just going to simplify that out. So this is going to be x squared minus 4x plus 4. So these two guys added together. And then from there, it's like, oh, this is a quadratic. We know how to solve these, right? But we have to have it equal to 0. So we're going to have to subtract x on both sides. I'll just line them up with their like terms. And we're going to get 0 is equal to x squared minus 5x plus 4, right? And from here, we're just going to factor. And so what times what is x squared? Well, we're like x times x. And here, what times what is 4? It has to add up to -5. So not 2 and 2, because that won't add up to 5. So it has to be 4 and 1, right? And then we know that they both have to be negative because it has to add up to a -5. So here goes, and -1 times -4 is +4. So x times -4 is -4x. X times -1 is -1x. And that's going to give us -5x. And again, note that this guy it's exactly the same as that middle term. So that's our check for that. And so in factored form, this is going to be x minus 4, x minus 1 is equal to 0. Now again, we're going straight across, not going diagonal. Don't follow the lines, okay? It's just going straight across x minus 4. And this right here is going to be x minus 1 right here. And then if you remember the zero product property, what does that say? That says that if you're multiplying two expressions and it's equal to 0, that means that both of those expressions have to equal 0. So, or one or more. So we're going to go x minus 4 is equal to 0, as well as x minus 1 is equal to 0. And this is how they're getting the solutions right there. So remember, we just add 4 to both sides, and we get the first solution, which is x equal to 4. And then we do the same thing with the second one, and we get x is equal to 1. So it's a good recap of what we did the last quarter as well. So we got those 4 solutions right there. And you're like, well, why did we get a thumbs down? Because everything's exactly correct, right? This is where we need to check. Remember, it doesn't look like Marty's checked. So we plug in the 4. So 4 is minus root 4. Is that equal to 2? And then we know the square root of 4 is equal to 2. So 4 minus 2 is equal to 2. So yes, that one checks out. So we do the same thing for 1. And we know that the square root of 1 is 1. So 1 minus 1 Yeah, that's equal to 0. We know definitely that 0 does not equal to 2. So x equal to 1 is not a solution. It is a solution that is not a solution. So the only answer is 4. So x can only equal 4. That's it. We got it. All right. So we're going to do the same thing here. I said I would do this. So try this one out. See if you can figure it out. If not, that's okay. It's also on the exit ticket as level 4, as something similar to this, not exactly this, but something similar to it. And also, if you did not want to do factoring, but you want to use quadratic formula, you would be able to use it there as well. So up to you which way you want to do it. So I notice here, I'm going to just use blue here. So x minus 1 is equal to the square root of x plus 1. So my first step, again, make sure you pause, try to do this yourself. I'm going to square both sides. And I'm going to get, remember, I have to multiply that out. So this is actually equal to x minus 1 times x minus 1. If you want to use the box method, please use that way. So this is going to be x squared. And then x times negative 1, which is negative 1x. And then negative 1 times x is going to be negative 1x. And negative 1 times negative 1 is positive 1. And this one, the square root and the square cancel out. So all we have left is x plus 1. This is going to simplify the left-hand side. So this x squared minus 2x plus 1 is equal to x plus 1. So let's try this. So I'm going to subtract everything on the right-hand side. So I'm going to subtract x on both sides. And I'm also going to subtract 1 on both sides. I'm going to kind of, since we're just adding and subtracting, I'm just going to do both of them at the same time. If you're like, that's too much, then, just do it one at a time. But you'll end up with the same thing. So we end up getting x squared minus 3x. Well, that's just going to be 0. So is equal to 0. Oh, looks like this one's going to be pretty okay. So again, if you want to use quadratic formula, you can. But this one's going to work out pretty easy. Because if you notice right here, we have a binomial. And they both have a GCF of x, right? So we could pull out an x on both of them. And so that's going to be x minus 3 is equal to 0. Right? And then so again, just like the zero product property, we're going to set those two factors equal to 0. So again, x is equal to 0 and x minus 3 is equal to 0. So we're going to have, well, x equal to 0 is already solved for. This one, you would just add 3 on both sides. So you're going to get 2 answers here. X is equal to 0. Actually, before I even go into, I should probably check it before I get any further of just like saying that that's the answer, right? So we're going to just plug those in. So we're going to put in 0 first. 0 minus 1. Is that equal to the square root of 0 plus 1? And if you notice on the left-hand side, it just simplifies to negative 1. On the right-hand side, it's going to simplify to just the square root of 1, which we know is just 1. The square root of 1 is 1. These are not equal. So yeah, we're like, no, that doesn't equal that. So x equals 0 is not a solution. So let's try for 3. Let's use a different color here. So 3 minus 1. Is that equal to the square root of 3 plus 1? So 3 minus 1 on the left is 2. And is that equal to the square root of 4, right? 3 plus 1 is 4. And we know that the square root of 4 is 2. So yep, good. So this is going to be our solution right here. So x equals to 3 is our solution. That's how that goes. Right, that's the end of the lesson. We'll move into day 2 tomorrow. And yeah, good job, guys. Bye.